Hi everyone, welcome. I'm happy to be here today to present this deep dive into a very discussed topic. On this day, it's Pulumi versus Terraform. Today, I would like highlight more Pulumi because it's a little bit younger tool than Terraform, and currently a little bit intro about today's session. Currently, the leader of infrastructure the code solution is Terraform, as we everyone know about it, which used by default on HCL language. Although this language is quite simple, it has own specifics, non-transparent different types, variables, and not always, and not obvious approach to loops or something tricky logic. In this presentation, I want to show another way to work in this infrastructure as a code using the real programming languages based on Pulumi. Those developers and ops team can use the best tools, best practices, technologies, development environments, familiar to them when working with the infrastructure. Okay, let's go. 2 words about me. My name is Kirill Kazakov, and I'm DevOps Engineer at GlobalDots from a web development background. Around 10+ years in IT industry experience and 5+ years at the DevOps way. By the way, it is important to remember that the technology is rapidly evolving. This is why I think we should share a fresh knowledge, and this is why I'm here. In 2 words about me, I'm a member of I Want to Know Everything, and I'm happy to share what I've already learned. Okay, we are GlobalDots. With unrivaled access to innovation, we are always on the hunt for emerging and innovation technologies, location best-of-breed cloud, security, and performance solutions from around the world. GlobalDots is active for 2 decades now, and we are a trusted partner for more than 400 global businesses, enterprises, and cloud-native organizations, focusing on DevOps, web performance, cloud management, security, managed services, and AI and machine learning solutions. And today, evening plan, let's start to discuss what we should pass today. I want to start a little bit from afar and take a look at the problem that Pulumi tried to solve. So we are starting from infrastructure decode requirements, modern requirements. Then we'll take a look at the Pulumi solution, what is it, and how it works in general, actually. After it, we take a look at the Pulumi architecture and how it works in more details. Then I would like to share a little bit demo, how it works in the practice. There we try with Pulumi a very beginner example with AWS S3 and check a cloud part of the Pulumi. Next topic, it's some of the Pulumi's feature benefits, extra feature, original features. And finally, we compare Terraform and Pulumi from some of sides and features and summarizing. Yeah, and intro. Modern architecture requires a more meaningful infrastructure approach when you describe your project. It is often necessary to implement flexible logic, which is difficult to achieve with the standard DSL languages like YAML, JSON, of course, and HCL. This is how the infrastructure description usually looks like. I have experienced what I've seen this picture 100 times. This approach we usually use in our infrastructure as a code. This model implies an infrastructure description process similar to the software development process, but often this process is not so smooth and easy when you are using the standard DSL. Yep. In order to simplify the process of describing an infrastructure and making this process more common, there are new tools devised working with many providers via API and support many existing popular languages. We are talking a little bit later about these tools. Besides Pulumi, there are some tools. Yep. So infrastructure as a code flow on the picture can look like a regular software development. And what we get from it, we will, with the true languages, we get all advantages of development, all best practices. We could use logic, if statements, for loops, use object-oriented techniques, define high-level abstractions, etc. It's high time to use Pulumi and to talk to Pulumi. What is the Pulumi? Pulumi fills a gaping hole in the infrastructure coding world where Terraform maintains a firm hold. Terraform fits entirely static infrastructure, but dynamic infrastructure definitions call for real programming languages. It's absolutely true. I faced to this issue not once. Pulumi distinguishes Pulumi itself by allowing configurations to be written on some languages like JavaScript, TypeScript, Python, Golang, and some else languages. Pulumi is tightly focused on cloud-native architectures, including containers, serverless, data services, and provides a good support for Kubernetes. One interesting thing, in October 2021, TechRadar moved this tool to the next step, to the trial stage. It's almost the last stage before very stable stage. That means it's a good time to try it. If somebody doesn't know what is TechRadar, TechRadar emerges from ThoughtWorks community of passionate technology across the world, like Martin Fowler, everybody know who is it, and other famous people in IT. Last important thing, Pulumi present themselves as not infrastructure as a code, but infrastructure as the software, because we write on the true languages. In this picture, you can see technologies and integrations that you can use with Pulumi. Of course, it's not a complete list of text. A little bit about architecture. Under the hood of the Pulumi CLI is the classical binary for such tools written on Golang. So we already have a client to work with different types of infrastructure and clouds, for example, with AWS or OpenStack. There are providers in Pulumi for different infrastructure, as well as in Terraform. The registry for all providers and extensions is located on the Pulumi website. At the moment, there are about 120 of them, but after a little processing, you can use Terraform providers. So it makes the provider set the quite large. and give you more freedom, because Terraform supports a lot of cloud providers. Interesting thing about Pulumi provider, Pulumi supports exactly all features available on cloud providers almost at the moment that feature is released. How and why? Because Pulumi achieved this due to native integration with the cloud API of providers. It's a very cool feature. After creating the infrastructure, we need to save the result of our work somewhere, and in other words, the objects that we created. For this, just like in Terraform, Pulumi used state, and like in Terraform, various backends are used to preserve this state. The difference here is that by default, the service manager is used app.pulumi.com service, somehow similar to Terraform Cloud. In addition, you can view the history of state changes and current resources on this portal. It's very convenient, I guess. Plus, you can deploy your own backend for Pulumi. It's extra cool feature. But no one forces to use this service. The client can be configured to store the state in other backends, like Terraform. For example, AWS S3, Google Cloud Storage, or simple local state on a uLocal disk. Another very important thing is migration from Terraform. I would like to highlight that Pulumi has put a lot of effort to make migration from Terraform tool painless and fast. There are various tools and approaches to achieve this goal. Now let's talk about the logical structure of Pulumi. This diagram illustrates the structure and major components of Pulumi. Pulumi groups infrastructure in the form of projects. Project is some kind of piece of infrastructure. For example, the entire network stack of an application in the cloud, or for example, a collection of AWS S3 buckets. This approach is called microstack, via one project, one folder. But it's not mandatory. You can use a monolithic structure via all apps in one project. Further, the stack in the project, usually stacks are created per environment, and they contain variables specific to this environment. Stack looks like workspace in Terraform. On this picture, we can see the same structure is shown, but we have 3 projects, for example, sample IAM, sample EKS, and sample app. Each of them has 2 stacks, dev and prod, as you see. In dev, there will be settings for development environment, for example, separate AWS account, region, etc. And in prod, you set your own settings, of course. On this slide, you can see an example of creating an EC2 instance in Amazon and in the JavaScript language. And Pulumi looks like regular apps. That means you do with these apps same action as regular apps. Pulumi provides describing new infrastructure with imperative languages, but strongly support declarative features. It's a very important point. Another thing, of course, if you use true languages, true programming languages, you will get all benefits from classical development software. On this slide, we see that we can use all feature and power of the language. For example, before creating objects in a bucket, we check the size of the uploaded file, and it's a larger. If this file larger than 500 kilobytes, then the objects will not be created. And if less, then in the loop, we will create 10 such objects with some automatically generated names. Yeah, and purpose. All these things are very convenient to use in complex scenarios. For example, in the case for Kubernetes deployment, we can simultaneously consume metrics, and if something went wrong, then quickly roll back. Yeah. So it's a little bit demo time. Let's program the cloud. On the right side, I have my best terminal. On the left side, I have my best environment tool, development environment tool. Yeah. Firstly, I have pre-installed Pulumi CLI. I also log it into the Pulumi web application, and I have AWS account for this demo, of course. So let's start. At the moment, I'm here in the one demo folder. Inside this folder, nothing. Let's create new example. Pulumi new. We have a few options to create this. First of all, we could create from scratch, create based on some language runtime, for example, Python, Golang, JS, or something else. Or we can create a new application, new stack from some template. It's pretty useful for, especially for these webinars like demo. Let's type Pulumi new, and Pulumi ask us what kind of template you would like to use. Let's try very simple application based on Python. It will be AWS Python. Okay. Let's name our project. It's a high level naming. S3 bucket py. Oh, sorry. Bucket py. Description, it's okay. It's by default from this template. Stack name is like a Terraform workflow. Dev, it's okay, but I would like to use demo. Okay. And region, okay, by default from my local environment. At the moment, Pulumi installing dependency to my local environment, to this directory, to use runtime Python. And then Pulumi asked me to run Pulumi up. I'm okay, let's go. And then Pulumi calculate some difference between desired state and a real state. Pulumi asked me what I would like to do, accept, review details, and reject. Let's interrupt to see our code. So we have virtual environment in our internal directory one demo. Then we have our code to create S3 bucket via Python language. Firstly, we import some library, Pulumi, it's base library. Then we import library to use AWS resources. Then we create this pretty simple resource like my bucket. Let's check it and change bucket name. Pulumi S3 bucket. Okay. Then we export this bucket ID to stack environment to reuse it next time. So what we have also, we have Pulumi demo YAML. It's a file which describe our stack. It's like environment. In this file, we can define some variables, specific variables for this environment. Then we have the main file like Pulumi YAML. It's a pretty common file which describes our project, our stack, our runtime. Yep. And requirements, pretty simple file for Python. It's these packages downloaded from the Python registry for Python, of course. So let's create our resources in that AWS account. Yep, I would like to accept this. Also, we could check our resources, our action in this web application. It's a web-based site of the Pulumi, which provided by default. Let's go to the link. Come on. Yeah. And here is pretty same like we see in our CLI. We have configuration, metadata, and some other fields. As we see, we have project name and stack name. Okay, I would like to accept it. Also, we can open by the link. We have in real-time Pulumi action. Oh, complete, nice. So let's check our bucket. As you see, we have Pulumi output. It's like a Terraform output. This variable saved in our stack. It's like a Terraform state. It's a name of variable, and this is a value of variable. Also, we could check our variable by this command, Pulumi stack output, then output name. Let's check it. Yeah, it's working fine. And then let's try to copy something to our new S3 bucket. Let's do something pretty simple like this. Hello from Pulumi demo, demo txt. Okay, got demo txt. It's okay. And let's add the bucket name to local environment for useful. Okay, and copy our demo file to our S3 bucket. S3, then our name of the bucket. Looks okay. Let's check it. So fine, it's working. Great. It was pretty simple example. Let's go further. But before, I would like to destroy my stack, my resources to reduce costs. Let's do it. Firstly, I should remove my file from the bucket because I can't remove bucket before at least one file exists. And then I would like to delete Pulumi down. That's it. That's enough to destroy. Also, I can verify what Pulumi would like to do. As we see, Pulumi would like to destroy bucket name in our stack. Also, we can review it in the web UI. As you see, yep. Let's accept. It's a new step. Also, we could verify it in the website. So done. Nice, perfect. Let's verify. Is there no my new temporary bucket? Yep, nothing. Nice, but let's go further. I would like to show you a little bit more interesting. At the moment, we have second demo. In this demo, I would like to create three resources. Security group, find MA ID, and create EC2 instance with pretty simple text. In this example, I would like to show you how to work with common applications, with Pulumi applications, like with the common applications. And in this example, I would like to use library unit test to create some unit tests for our environment, for our resources. It's a pretty common testing framework for Python. Yep. So I'm importing unit tests as well, and of course Pulumi library. Then I create a few mocks, so we don't need to create real stack to check to run our unit test. Of course, that's why we use unit test. Then I import my infrastructure from this file and create three tests to verify is there tags in my EC2 instance. Yep, is name. Then I check if there are some user data. If there are no user data, and then check if there are open 22 ports for everyone. If it is, then test will be broken, will be failed. So firstly, in this example, I would like to create a virtual environment, Python 3, and create. Also, I already have this environment. Then I would like to activate it and to install dependency. From requirement txt, done, perfect. And then we could run our tests by run PyTest. And just this one flag, disable PyTest warnings, because could be a lot of warnings. So let's check. As you see, 3 tests passed, done. Okay, let's verify how test will be failed. Just open 22 port in our security group for everyone and try again run our tests. As you see, our tests failed. Then it's that desired behavior what we would like to do for this demo. So that's it for our demo, I believe. Okay, let's continue. Little bit more about extra feature of Pulumi. I would like to highlight some amazing feature. This feature called Automation API. You can create a new classes as software as a services that provision unique infrastructure for every customer. How to do it? You can see on this picture implementation, you can build a perfect cloud interface for your organization, combining all of your infrastructure knowledge and best practices into a purpose-built tool, whether it's a SaaS offering, an internal web app, purpose-built CLI tool, CI/CD integration, or something else. From my point of view, it's a unique, very, very cool feature. We're almost the finish line. Let's look at Pulumi in comparison with Terraform. Instead of 1,000 words, take a look at the picture. I will describe this picture from left to right side, and I would like to start from second line. First option, first point is AWS SDK. This tool provide AWS, as you know from the name. You can describe your infrastructure in real programming languages. Then it will be compiled to the cloud formation template, as you see on this picture. Next one is Pulumi. With this tool, you can describe the same infrastructure as a code in real programming languages, but you can see a native API. It's a native providers, then communicate directly with API providers. You can, another thing, important thing, as I mentioned above, Pulumi can reuse Terraform providers. It's a very, very cool feature. And Pulumi also could convert HCL language to the Pulumi code. It's another interesting and important thing. And also, Pulumi could use a special operator, Kubernetes operator, and there is fascinating GitOps case in cooperation with Pulumi and Argo CD. So next, a little unexpected thing. It's a Terraform. Terraform has some wrapper called Cloud Terraform Kit for Terraform. This is an additional layer. It uses the AWS Cloud Development Kit, SDK. I believe a few years ago, HashiCorp joined to AWS and in cooperation create this project. With this solution, you can also describe your infrastructure as a code in the real programming languages. Then this code will convert to JSON. It's an important thing, and used by classical Terraform tool to deploy. Why I said it's an important thing? Because it's additional layer, and it's one more stage to complicate whole integration and converting from one side to another side. This solution is younger than Pulumi, and most recently this solution was in beta and was not recommended to use in production. You can use CRD with this solution also, but as I mentioned above, this solution in beta and some time ago, not too far, and not recommended to use in production. And the last thing, last line, it's cloud providers which consume the infrastructure as the code via their API calls. Pretty simple from first glance. Okay, on this slide, we create EC2 instance on the left side with Terraform using HCL. On the other side, with Pulumi using Python. So for the first glance, these two parts looks pretty similar, but maybe HCL side looks like more simple. Definition and value, that's it, nothing else. And I can't provide in this presentation a whole difference between Pulumi and Terraform, but I have some interesting thing to compare these two tools. I would like to highlight a dynamic provider. Dynamic resource providers can be written in any languages you choose because they are not shareable. Dynamic resources provided do not need a plugin. It's about Pulumi, of course. Terraform doesn't have any analog of this. Two cases, for example, you want to create some new custom resource type, for example, or maybe you want to use a cloud provider that Pulumi doesn't support. For example, you might want to write a dynamic resource provide for WordPress. In nowadays, a little bit funny. Pulumi pays a special attention to secrets. It's another very important thing. You will not find plain text in open form in the state file, unlike Terraform. You have also an audit capabilities thanks to native languages. Other interesting things, you can use embed application code via automation API, which I mentioned above. Create a great feature is importing code from the Terraform. This gives you more freedom. Really, you can convert your HCL from Terraform or import real code to your Pulumi project. Who's using the Pulumi? I believe everyone knows these names and almost all names. Of course, it's not whole list. And I would like to summarize our evening. We already discussed the pros of Pulumi. Let's consider the cons. You must program in the real programming languages. It could bring an additional complexity to your project, to your team. Another thing, you can see on the last point of cons, support for the Pulumi side, it's not very cool. That means your issue could be resolved longer than in the Terraform case. On the last point, you can see numbers of employees of Pulumi company. It's actual numbers to 2021. In compared to Amazon and HashiCorp, it's a big difference. So you should understand your risks. And in the end, my verdict is there is no winner and no loser. Each tool has their own pros and cons. It's up to you. Project, firstly, requirements before anything else. You should exactly to understand it. Pulumi is more flexible and has more features, but it's a more complex and younger solution. If you need to implement some complex logic, you need some extra feature which doesn't support a Terraform, you really hate DSL or HCL or YAML, then I would suggest to use Pulumi. From the other hand, Terraform is simpler and has fewer features, but it's more stable and has more community support, cases, examples, documentations, etc., etc., etc. In my personal opinion, more than 90% of infrastructure code has a DSL definition without any tricky logic. That means we shouldn't increase complexity of our solution of our code, but we should decrease either. If you are looking for a long-term stable solution for critical infrastructure, then I would suggest to use Terraform. Eventually, you can use Terraform and Pulumi together. Moreover, Pulumi supports import using Terraform states and a lot of other Terraform features. That means you can take some variables from Terraform states and reuse it in your Pulumi project. So that's what I wanted to share today. I hope you enjoyed, and it's as much as I did. Thank you so much.